I'm Pierre-Yves Le TRAON, Scientific Director at Mercator Ocean International. I'm really honored to be here today to give you an insight of the Copernicus Marine Service to explain how it works with the architecture, the observation, the models, and the services. We are celebrating today the 10th anniversary of this service. As Pierre said, it's an operational service for 10 years, so it's an important event. It's a very strong European achievement because it is a state-of-the-art service that is used globally, and I will explain how it works. So I will first explain how it functions, how it works, the architecture. Then I will explain the evolution of the service. It is essential when we have operational service on the ocean to make sure that we are currently improving them to stay at the top and on the state of the art. And I will then talk to you about the observation, which is a crucial point to analyze the ocean. We need the observation of satellites and in situ, and I will explain how we operate, and I will end with some examples and some applications. So, I just want to remind you of something obvious, but why did Europe implement a specific marine service? Well, it is because of what is at stake for the ocean, so it's to understand the evolution, the role on climate change, and to adapt to climate change, but also better protect biodiversity and to meet the blue economy agenda. So as it was said, the ocean is very high on the political agenda. So today we have this unique conference in Nice where science meets politics, to really guide the politicians with knowledge, and the service that we have today with the Marine Service of Copernicus, which is an operational one, is very useful here. So just in a few words, what do we do with this service? It's been there for 10 years. We describe and we forecast the ocean, so the blue ocean, so the physics, temperature, sea level, stability, salinity, and the sea ice. So we do this from observations, from models. So our observations integrate the models. They're assimilated. So it's the same as weather forecast activities, and we do this in real time for 10 days. But we also look back on what has evolved in the ocean to better understand climate change and its predictions. So here is an example of a Mercator Ocean forecast. So this is implemented by the Mercator, but it relies on a whole network of forecast centers and monitoring. So here is a global ocean forecasting done by the Mercator system, so less than 10 kilometers. Here we have all the observations that are available. So the satellite ones, I will get back to it later. We also have Argo Balize here. All of these data are combined within the model to describe and to forecast the state of the ocean. So these are unique capacities here in the world today, thanks to this marine service and thanks to Mercator Ocean. Here we are really at the state of the art globally. So if we look into more details here, what do we offer with Copernicus Marine? We have observation products, so physics, geochemistry. With the sea ice, this is done under the Copernicus Marine Data Store. All of the products are defined. This is very important on the operational service that we provide, is that there is quality here defined by the standards analyzed, and it's essential when we provide such quality products. And of course we have a service desk with different expert advice level to guide the users. We also have visualization tools that are used. This allows to have 500,000 people online every year to visualize the ocean as as it's evolving thanks to our tools. So I was talking about the quality monitoring. So we have a real effort to really be at our best quality, and this is done within global coordination. So we put a really big effort into working together globally to describe the quality of our products. So s- we, we don't only give observations and analysis, we also give indicators. Every year we publish the ocean state reports and a review for global decision makers, giving knowledge information on the monitoring of the ocean state. These indicators are extremely important. Here are just a few examples. So we have the monitoring of the sea, for example, the sea level, the average one with the satellite, but also everything that happens in Arctic or the Antarctic. We need satellites, but also what we have in within the sea to see the monitoring of the temperature, for example. So for users today, we have over 100,000 subscribers using our products regularly. We have a lot of visitors as well, and we cover all of the application uh, sides. So this is a pan-European service. So for example, for maritime transport, for aquaculture, for fishing, but also for climate and adaptation. So all of these users are using this service. So here is a map of all the users of the Copernicus service. So here we have a global impact, as we can see, with Asia growing currently. So we have worked on an ambitious plan with the service. It started in 2014, 2015. Now we have a new phase until 2028. We have an ambition here for biology, for coasts, and as the mayor just explained, coastlines are extremely important. We have a lot of challenges there, so we really need to work on it specifically, and also all these synergies with the digital twins of the ocean that will be introduced later on in this session. Now, on the architecture, very briefly, we work with a set of producers in Europe with modeling centers, with monitoring ocean centers. So we have modeling centers for models, and we have a management of these products thanks to this marine data store where we gather all of the products within the system. And in the upstream, we have all the observations. These are extremely important. This is why I'm talking about them again. And afterwards, the applications downstream. Now, on the marine data store, it's an essential element of the data of the service. It's based on the cloud. It's extremely efficient, and it is also developed with the digital twin of the ocean. Now, in the evolution of the service, as I was saying, it is essential when you have an operational service such as ours to make sure that it meets the need of the users and of science evolution. So we have a whole strategy that's been implemented for 10 years to make sure that this evolution is there. So this is done with scientific committees, with science users, to interpret these evolutions. So we really are a user-driven service. So we are based on the user needs. So we have a whole work done on collecting the user needs to make sure that we know their needs and to integrate them into our evolution. So this is what we have defined in our coming years plan. whether it's on the coast, on biology, on the digital service linked to the digital twin, and on the climate as well. So, without getting into much details, but when you have an operational service such as this one, it's important to organize research towards operations. So, we have a whole system there with specialists to make sure that we have that from the research we turn that into operations. So I'm not going to get into details, but we have many mechanisms to make sure that we constantly try to improve our service to make sure it meets the user's needs. So I will talk about science. We really want to use the best of science for the evolution of service. So we have a science strategy to meet the user's needs. So we have many themes that have been defined where we develop roadmaps for our evolution. So this is the way we work on the different evolutions with short term, mid term, and long term. I want to say something very important for us at European level is the Horizon Europe program on research and development, and we have pathways to improve our systems in the long run. Now, one word on AI. It's an essential point in the evolution of our service. There is a major, huge potential for improving what we do today for data processing, for monitoring and our forecasting, or improving our models. So it's an important directions for Copernicus service. Now I'm going to talk on the last part on observations. We cannot, with weather, we cannot predict the ocean state if we don't observe it first. So the essential part is to observe the ocean correctly from the space, but also from in situ measures. So we do depend on these capacities, whether it's Europe. With Copernicus, Europe has unique capacities to observe the ocean and the planet from space. It's the Sentinel program, so we use this program. We also provide information to guide the evolution of these services, and we also depend on in situ measures, so the global ocean measure system that we depend on and that we use, and we also give them recommendations for the evolution. So this is to explain all of these recommendations that we can make to guide the spatial agencies, the European Commission, but also the Global Observation Ocean Services. Here you have the different Sentinel missions that we use. So it's Sentinel 1, 2, and 3, and 6 for the ocean, and also new missions coming in the future, allowing us to better observe the coasts and the biogeochemistry and the polar areas, especially on the Arctic. So Virginie will introduce later on the Argo program. It's an essential program for us. It is the equivalent of the radio surveys for the atmosphere. So without them, we would not be able to make analysis and forecast for the ocean. So it's a major forecast tool for us, for other parameters as well. So all of the data that you see here, every day, they are integrated in our model. So I will be very quick. So as every operational center, we look at the impact of all of these data. So here, if we remove the Argo data on the quality of a system, we see that we have a lot of errors, large errors that occur. And you will have an presentation later on the new satellite observation capacity. So we have made observations on how this satellite will improve our predicting and forecasting ocean capacities. So we see here how it can be improved, and it's essential to help with the development of these capacities. Do I still have a few minutes left? Oh, well, you have to be done actually, but I'll be very brief on the application and the user. So here is an example on the activities and on sea ice, on maritime transport, all the information. Here is another example on the sargass. sargassum seaweed. So what we do with our service really helps to have the satellite observation to detect them, but also the capacity with marine uh, currents to see where this sargassum seaweed lands and to guide then the politics. One last point on floods, on aquaculture here. Also, we also use our observations for aquaculture. We need information on the quality of water, on the temperature, the salinity, and oxygen for the aquaculture industry.
I think Kenish will be there a bit later to tell us that these are part of the solutions we are presenting. And a final point, and it's a very important point when you talk about biology and biodiversity, all the information we're giving you are also very important to protect biodiversity, because we have marine habitats and we have protected species like sea turtles, as illustrated in this room. These habitats depend on the salt levels and sea quality, and we can actually categorize these habitats. We also work in international collaborations. We don't work in silos, and this is why we have a lot of interactions. So in order to conclude, thanks to the maritime service of Copernicus, we have a state-of-the-art tool to predict the quality of the oceans. It's based on the in-situ models, and we have a lot of work, a lot of operations since 1990, 2014. So also have many opportunities to improve our observations. We work with digital twins, and we have broad international impact and many collaborations. And we started just this week something we call a call for action to be mobilized on a global level so we can improve our forecasting capacities, and we keep on collaborating globally, even though the context is very difficult. But you know that it's important to improve our capacities and skills to serve society better. Sorry for being too long. I think it's pretty much like a weather forecast. We always have time constraints. Nonetheless, I still have a question for people who may not know it and people listening to us on social media. Do we agree that all this information, all this data are freely available on the Copernicus website? Yes, it's true. It's the motto of Copernicus. We have free access for everyone. It's important to develop our applications and to serve the public. So do you agree that thanks to the applications, we can zoom in and we can focus on specific coastlines, places where we live? We can have more information about salt levels, and you can zoom in on specific areas. Yes, you have a few demos available in the venue, and you can actually zoom in on places you're mostly interested in. Thank you, Pierre.